So just before we start doing all the organic homologous groups, we'll just go through the terminology that we're going to use. So first of all, is hydrocarbons contain only hydrogen and carbon. So that doesn't cover all the homologous groups. As soon as we start having the oxygens and the nitrogens in there, which is pretty soon, then they are not hydrocarbons. They're organic molecules, but they're not hydrocarbons. So just the alkanes, alkenes, alkynes. Everything else starts to have oxygens and nitrogen in it, I believe. And so the homologous groups, you're going to have to find a way to know the formulas because they like to ask those. There are ways to work them out. But generally, once you've got a homologous group, which is basically just a functional group, you're usually just adding CH2 on the, continually adding CH2s to make the chain longer and longer and longer. And so the carbon just increases by one on the whole. And each homologous group, each class has the formula on the front page, which is where I'll start. Okay, molecular formulas you're aware of already. They're sort of the the lowest whole number ratios, empirical formulas if it's a covalent network solid. But if it's a simple covalent molecule, it is the actual number of elements in the compound, which is basically what we're doing. Pretty much all of organic chemistry is simple covalent molecules, so that they start to get quite large and not so simple. The structural formulas are the ones you're going to need to draw in the exam whenever they ask for a compound. Draw the full structural formulas. In the meantime, you may get presented with a condensed formula, but don't use that. If you're writing out a structure, you need to show that you know where the bonds are and how many there are, where the doubles and triples are, etc., and what's joined to what, such as OH. If it's not OH, if it's an alcohol. Empirical formulas we've already talked about, and skeletal formulas is what I use in class probably because that's getting super lazy. Just note that they're carbons at the end, but if you actually have a functional group at the end like an alcohol, there's no carbon there, that's just like that. Okay? And last of all, for isomers, which we're going to cover soon, this is on the page, and this is how we represent it disappearing. It's going out behind the page. You can't see it. This is coming out hitting you, so it's all dark and solid and clear. So that's the wedge. So that's called a wedge and dash projection, or I think your syllabus calls it a stereochemical formula.